So, can anybody explain, like, what are some of the things that are involved in number 12? Like, what do you have to do? Substitution's one of them, and then the more obvious one, you're just going to add, right? Yeah, so substitution, and they want you to add two of them together. So, the one on the left, hopefully you recognized as being the geometric series with a substitution, right? So this would be 1 minus x plus x squared minus x cubed plus ... I'll just leave it at that for the moment. And then the other one, of course, is just the regular old geometric series, right? So it'd be 1 plus x squared plus x cubed plus ... Make sense? So, if you add these up, you would get 2. The x's would add out, right? Plus 2x squared. And then the x cubes would add out. And I have completely run out of terms, right? Because I need the first 4. Oh my gosh, what do I do? I could add some more. Is there a pattern established? Can you start to picture the pattern that would result from this? What do you think would come next?
2x to the 4th.
Plus 2x to the 4th, yes. Plus 2x to the 6th. And I finally got into my 4th term, so I did what it said. Other than the general term, we haven't done that yet. What do you think? So a substitution, then an addition. Okay. So then what do you guys think about an nth term? What do you suppose that would look like? 2 times x to the 2n. What do you think? You guys agree with that? Okay. So what's my n starting value if we use that?
0.
Yeah, if n was 0, I agree. Okay. Interval of convergence. Let's do this. I think this would be a good time to tie this in. What do you guys think? What would you guess the radius would be? Or should we just investigate? 1? Okay, let's find out. So I'd go limit as n heads towards infinity. And then we'd go the n plus 1th term. So that would be 2x. It'd be 2 parentheses n plus 1. So it'd be 2n plus 2. Over 2 times x to the 2n is hopefully less than 1. You see right away the 2's cancel out. We end up with x squared. So limit as n heads towards infinity of x squared, which is less than 1. What do you see? Do you still see a radius of 1 here? I do too. Yeah, that makes sense. The limit as n goes to infinity doesn't apply to anything anymore because all the n's have canceled themselves right on out of there. So I'd end up with, actually I'll do this. I'd go absolute value of x squared is less than 1. There's no way that this is going to happen. Right? And so the only thing that really comes into play here would be x squared is less than 1. And so I don't know how far we need to take this. Can you see that the only numbers that work would be the ones that are between -1 and 1? Yeah. Okay, so I'd come up here and I'd say -1 to 1. But I don't know about the whole open-close thing. Going back to my nth term, if x is -1, what do you guys see? Convergence or divergence? So I'll go what do you see? 2 times -1 to the 2n. Converge or diverge? Diverge. Why?
Yeah. But, I mean, you just do the nth term times
It's the nth term test, right? Yeah, it's just going to be bouncing back and forth between 2 and negative 2. Although, actually, I don't even think that. I think it'll just be 2 the whole time, right? Because the exponent's 2n. Negative 1 to an even would just be 1. So I think it's just going to be 2 plus 2 forever, right? So I would say diverges, and then nth term test.
Do we have to write that down when we're testing the limits or the bounds?
Yeah, give a reason for it.
We have
Harmonic series, alternating harmonic.
Okay, so we can't just say we can't just say that we can't put a line there and be like, okay, that's
It just diverges or converges for no reason. Yeah, just give a reason. It's a harmonic series, and they always diverge or something like that. Yeah. And then if you can see that, you can probably see that we get similar behavior at 1. So 2 times 1 to the 2n also diverges for the same reason, nth term test. So I'd go back and I would erase those little question marks. That's my interval of convergence. All right. Questions? Okay, so I'll give you a choice here. 13 and 14 have to do with integration. 15 is kind of like what we finished with last time, where you're like a detective figuring out which function made this power series. What do you want to do right now? We'll do all of them. What do you want to do now?
Second function. The second.
The detective one?
Yeah.
Okay, so let's take a look at 15. We'll come back to 13 and 14 at the end. So here is 15. Yes. So f of x is given by that power series. Give the Maclaurin series for g of x, and g of x is equal to x times f of x. And then here's the detective part. Express g of x in terms of a known function rather than a power series. So as I walked around, my advice for folks was this. Write down the power series for g first. So here's what I would do. I would say g of x, if it equals x times f of x, would be x times all these terms and if I am going to try to figure out what function this comes from, I probably should distribute that x in there, right? So I'd say g of x equals x plus x squared over 2 factorial plus x cubed over 3 factorial, so on and so forth. My nth term, I could write it a number of ways. Here's one way. Or you could just write it as x to the n. I don't know. It depends on how you want to write it. Anyways. Does that make sense? So then what we're supposed to do now is look at all of this and look at that perhaps and ask ourselves, where did this thing come from? Like what function produced this?
where did it go?
E to the x? So this is just straight up e to the x.
Not quite.
But it starts later.
It's just
It starts at n equals 1.
Well, so what does e to the x? Well, if it starts at n equals 1, my first term would be this. That's not my first term, though.
no, it's not. It's the second term.
Second term.
0.
Okay, so if we start at 0, it would be x to the 0 plus 1 over 0 plus 1 factorial. That agrees.
It works.
Okay? But again, I ask, is this e to the x? Is that equivalent to e to the x?
Not
Let's write down the power series for e to the x. E to the x power series is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, dot, dot.
So are those supposed to be like straight equal signs or wiggly?
No, they're squiggly boys.
So it's a power series, and a power series, basically we're talking about it goes on forever. So I'd say equals. I put this here just because I'm not going to write the nth term right now.
Oh, okay.
In any case, what's missing from my red power series that's in my purple power series? So the red power series is the same thing as what? E to the x minus 1. It's e to the x straight up, but we're missing the 1. So you just subtract 1 off. That's what it is. It's e to the x minus 1.
That's crazy.
Okay, questions? Anything at all? All right, so then we're down to the final 2. Congratulations, you're almost there. Number 13. Let's do 1, 3. Okay, so 13. And this is worded very specifically. It says using integration, but notice it doesn't say using only integration. It says using integration somewhere in there. Right, the first 4 terms, general term for the power series for f of x equals natural log of 1 plus x. And I don't know if we'll do the interval of convergence or not at this point, but the idea is going to be using integration somewhere, somehow, some way. What's the power series for natural log of 1 plus x? So I'll let you ponder that for a few. Go ahead.
Is it just like use it for
Just take it.
Is it just use it for anything? Like if I use it just anywhere in this problem?
Yeah, I think you only need to use it once.
What if I use it in a way that you're not thinking of, but I still use it?
If it's all valid math, that's great.
Oh yeah.
Make sure you're careful. It's right here. I never edit it.
Cut out. Go.
Unless I have to, it should be a first. Okay. Maybe we'll do that at the end or something, sure. Hey, I saw some really cool strategies as I walked around. Here's one that caught my eye. I think what you were thinking is if I'm going to use integration or an antiderivative, maybe thinking of it backwards might be helpful. I saw some people that did this right off the bat. They said, well, if f of x equals that, f prime would equal this. And I felt like for some of you, this made a big difference as far as helping you with direction, right? So if f prime equals 1 over 1 plus x, if you did it this way, the hope would be that you would look at this and recognize that it's geometric but been changed a little bit, right? So normal geometric wouldn't have the plus, it'd be minus. So maybe you would write this as really 1 over 1 minus negative x. And then realize that it's simply a negative x substituted into the geometric series. So it'd be 1 minus x plus x squared minus x cubed plus dot 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 plus negative 1 to the n, x to the n. Right? And then once you get there, you could arrive at this idea. If I just do an antiderivative of both sides, it would be x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the 4th plus dot 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 plus negative 1 to the n still. But it would be x to the what? Have you guys figured out your nth term here?
N plus 1.
Yep. Over?
N plus 1.
Over n plus 1. And I hope you guys have noticed this, that we did this earlier. We did this like last week. If you're integrating a whole side, just go ahead and integrate the nth term. Negative 1 is just going to go back and forth as a constant negative or positive, right? And I think, let's double check and make sure we have the cadence on that right here in a second. But the x, the antiderivative of x to the n is just x to the n plus 1 over n plus 1. You guys have known that for a really long time. Don't let the fact that it's a series overcomplicate it. Let's just double check. If I'm starting at 0, and I think the cadence is right on the negative, positive. I think it's good. Brandon, did you have something?
I was just wondering, like, could you technically start it at 1 instead of at 0 and have it be?
Sure.
Okay,
And then it would be
still
x to the n over n, but then it would be negative 1 to the n plus 1 or something. Sure.
That still works as long
Totally.
as you just have the...
And you don't even have to define what your starting end value is. It just has to fit a pattern. And so if your pattern is a little different than the one that I thought of, it's just on me to figure out, does yours actually make sense?
Okay.
And I'll just, for goodness sake, please don't start your end value at like 64, just to be weird.
Why would I do that?
I don't know, just to be a hassle or something. But yeah, it would be on me to say, hey, I started mine at 1, he started his where? Oh, at 0. Hey, look, it works.
Okay.
Great.
Do you
So-
have to say where it starts?
Nope. Just put a pattern there and we're good. And then, of course, as we know from before, this is ln of 1 plus x, and that's equal to, I'll just do this because I already wrote it. Or even better, how about this? Okay, great job. Any other questions? Yeah.
Does so like with the geometric series, when you had it, it only converged from like -1 to 1, but when you take the integral of it, does
Yeah.
it converge from more than that?
So the radius shouldn't change at all. Should still be a radius of 1, but the endpoint behavior could change. Did you guys figure out the endpoint behavior on 13? I know you were figuring it out on 14.
They both converge.
Both converge? Okay, that's very possible. So what I would do with this, if I were going to find my interval of convergence, I would say integration shouldn't change the radius. So I would start here and say, well, I don't know about the endpoints yet. And then I would put in my endpoints, and I think, okay, I see where you're going with this, because if you plug in a -1, it's still going to alternate. So it'd be an alternating harmonic for -1, and it would be an alternating harmonic for 1. So I think we'd go back and say, I believe it would be double closed. I think that does make sense.
Okay.
And if you were prompted here, you'd want to show the analysis with your alternating harmonic and alternating harmonic or whatever, but just as a quick way to write it down.
If it just wanted the radius of the convergence, is it sometimes easier to find the integral and find the radius of that one, because you know the radius won't change?
Find the integral and then find the rate.
Find like the radius of the before you take.
Oh, the original? Sure, yeah. If you feel like that would be easier, I think that'd be fine.
Oh,
Yeah.
wait.
Nick, you had a question?
Well, -1,
Yeah.
that one diverges.
What, the -1 diverges? So it's
The top is always.
open closed?
Yes.
So it's that right there? Oops.
That was my question too.
Okay.
Could you just do that whole thing really quickly?
Sure, let's do it. So I would start here. Oops, hang on. Oh, not what I wanted. So I would start here, -1 to 1, and I don't know about the endpoints. So then I'd come over here and do my endpoint analysis. So for x equals -1, my sigma would be -1 to the nth times -1 to the n plus 1 over n plus 1. Oh, interesting. Yes, you'd get -1 to the 2n plus 1, wouldn't you? Okay, so interesting. So this would be sigma equals 0 to infinity. It'd be -1 to the 2n plus 1. And regardless of input, isn't 2n plus 1 always going to be odd?
Yeah.
Which means it's not an alternating series. It's just a negative series. -1 to an odd. So this would diverge. And the reason why I would say is that it's a harmonic series. It's not an alternating harmonic. Yes.
So when you say the interval of convergence only is between -1 and 1, does that mean you can't use this series to estimate the natural log of 3?
Oh, Oh, no. I see what you're saying.
X would have to be 2.
I would say your question, you are correct. You could not.
Okay.
Yes.
So you couldn't make a series where you'd be able to represent the natural log of 3.
Just change the centering point.
Oh yes, yeah. But you can't expand the radius.
No, I don't think so. So Liz, the other one is this. Like if you plug in a 1. So if you plug in a 1, that negative 1 to the n is going to alternate, and the 1 to the n plus 1 is just going to be 1.
So it converges.
So it's an alternating harmonic, which converges. So alternating harmonic would be the... That's not really reasoning, but that would be what it is. Bless you.
Okay.
So I'd come back up here and say negative 1 is less than x, which is less than or equal to 1, is my final interval of convergence.
Okay. Cool. That makes sense. Thank you.
Yep. And if you forgot the radius, go all the way back to the ratio test.
Okay.
Okay, guys, the final one is 14. We've got 8 minutes. If you haven't already looked at 14, please do. It's it before, yeah, this is it.
I'd like to kick my mom.
Wait, this is like all the way through.
I'd like to thank Wolfram Alpha.
I'd like to think.
Yeah.
Their flashcard app is good though.
Did you know that Chegg is almost easy vid?
I did know that.
I did, because they screw up my bibliographies every freaking time. They're like,
Okay.
watch this ad.
It's about that time. I want to get you guys out of here. It's Friday afternoon. Get you out of here on time. What did you see when you saw using integration and then you saw arctan? Derivative of arctan, yeah. So maybe you would write that down and say, well, I don't really know how this is going to go other than I got to use integration. F of x equals arctan. Why not think of this? And then the hope is, what's that?
I was just saying. But they were laughing because I was saying it.
Okay. Well, is it so? I think this is a great strategy because the hope is that as soon as you see this, you would see, oh, that's just a geometric series that's been messed with, right? Okay. So this would equal this and that. Something along those lines, I think.
Why is there a factorial?
How did I get what? The which series?
What was the substitution?
So I started off with this. Oh goodness, where do my factorials come back? Well, I'm wondering what they're chatting about partially, but they also refuse to whisper.
Yeah, they're just terrible. I hate them so much.
It's all good. I was about to say it's all good stuff, and then I heard what they're actually talking about.
This is actually so.
Could you guys in the back be a little more quiet, please? You're messing me up. Okay, then I substituted negative x squared.
Okay.
Make sense?
Yep.
Okay. So we get there, and then the hope is that you would realize all I have to do is an antiderivative of all this stuff, and I'm in good shape. So it would be arctan of x, which is what we were shooting for in the first place, x minus 1/3 x cubed plus 1/5 x to the 5th. There's my fourth term. And my nth term would be x to the 2n plus 1 over 2n plus 1. And I always want to make a double check to make sure that the cadence pattern for my plus minus is right. So the way that I've written this, I'd be starting off at n equals 0. And if n starts at 0, that negative 1 to the 0 would be positive, which does match my first term and the subsequent term. So I would say that that's good. Interval of convergence perspective, you guys came up with double closed. Double closed. You could confirm that by doing your, I think it would be probably an alternating harmonic on both, right?
Yeah.
So, question?
So can we just rewrite the interval of convergence? We don't have to do the ratio test or all that nastiness unless it specifically says to.
Yeah, so I'd say on something like this, I think I'd be okay with you knowing the radius right away. Like I feel like you should know it. Endpoints, I'd want to see some analysis. If it's like, in other words, it's an alternating harmonic, therefore it converges, like that would be the extent of your analysis
Okay.
for the
Do
endpoint.
you have to write the series notation?
Like with the sigma,
Sigma, yeah.
I would say if x equals -1, then this, and this converges because of whatever. Like we've typically done.
It takes like not even half a second.
Have a good weekend. See you all on Monday for your quiz. Have a good one.